Okay, welcome back to my channel. So the first video I posted under calculation for dimensions of various physical quantities in physics. Most students are still confused on how to calculate for the dimension of physical quantities. So in this video, I want to explain step by step on how you can calculate the dimension of any physical quantity. Okay. So we are asked to calculate for the dimension of acceleration. So the first thing you need to know is the formula of that particular quantity. Are you getting it? So what is the formula of acceleration? You know, the formula of acceleration is what? Velocity over time. So this is the formula of acceleration, right? So the next step to take is to know the formula of velocity. And the formula of velocity is what? Displacement over time. Displacement over time. This is the formula of velocity, right? All over this time here. So the next step is to multiply these two times together. Are you getting it? Or we can write it this way, equal to displacement over time divided by time all over 1. So we have displacement all over time. It will change to multiplication when 1 moves to the upside. Then we bring the time down. So displacement multiplied by 1 will give us displacement all over time multiplied by time will give us time square. Are you getting it now? So we have displacement all over time square. Are you getting it? So in my previous videos, I said the approved theoretic quantities we are going to be using in writing down the dimension of any physical quantity are what? Length, mass, and time. Those are the approved quantities. We have length, mass, and time. So the symbol of length is what? Is L, while the symbol of mass is what? M, and the symbol of time is what? Is T. Are you getting it? So in displacement, we can represent it as what? As length. So in writing down the dimension of any physical quantity, we have to change everything in order to correspond with these approved theoretic physical quantities. Are you getting it? So in the place of displacement, we can represent displacement as what? As length. Are you getting it? So in displacement, we can write it as what? As length. While the symbol of time is what? Which is time is t square. So let's write the dimension of acceleration. This is what we do. Bracket open. You write the three approved quantity, which is L, M, and T. This is a symbol of length, M is a symbol of mass, and T is a symbol of what? Time. So we have G all over T square. This is a symbol of what? Displacement, right? While T square is a symbol of time square. Are you getting it? So in order to write down the dimension of acceleration, these are the approved theoretic physical quantities: length, mass, and time, right? So I said it before, I said in the place of displacement, we can represent it as what? As length. So meaning we have L all over what? L all over T square. So now let's write down the dimension of acceleration. So we see that L is present here, right? Also, time is present here, but mass is not present. So this is what we do. Since L is present and L is the numerator, we represent it as 1. But M is not present, which is mass, so we represent it as 0. While time is present and time is the denominator, so we write t raised to minus 2. So this is the dimension of acceleration. Are you getting it? In case you don't understand, you can rewatch the video. So let's write down the unit of acceleration. So from this formula, we can write down the unit of what? Acceleration. This is length, while t square is the time, right? So the unit of length is what? Is meter. Meter per. While the unit of time is what? Is second. So meter per second square, or meter second square. So this is the unit of what? Acceleration. So this is how to calculate for any dimension of any physical quantity. Okay, thanks for watching. Like and comment on this video, and don't forget to share. Bye.